I appreciate you stopping by to check out this episode of Vintage Audio Review. And before I actually get into the review portion, I wanted to give kind of a little channel update. The first thing is I thank you all who have subscribed and leave comments and give me thumbs up. Predominantly I get thumbs up unless I'm talking about speaker wire. And there was a few thumbs down, but predominantly most people seem to like the videos. And right now I'm recording this in mid-August 2024. I'm pretty close to 2,800 subscribers. I thank you. And when I hit 3,000 subscribers, I will try doing a live stream. Hopefully there will be more than just one person on my live stream. So that's kind of something to look forward to. I only am going to release one video a week. I've been very faithful. They're basically loaded 2 to 3 videos ahead of time. It allows me to work a little bit easier on them and not rush to get them out and all that. And so that's why this one is probably going to be going out, I would say, maybe mid to late September. We'll just see how things go with the other videos. I actually recorded, a lot of things that I test and review. All the work is done, and then I kind of go through and try to pick the oldest one that I haven't put together as a video and work on it. So that's kind of how I do things. I don't like to rush, and sometimes I have to repair stuff, and so it takes a little bit longer. So I just appreciate your patience and sticking with it, the channel, and the best way to make it grow is subscribe, like it, watch most of the video if you can, and to leave comments. YouTube has some algorithm on what they track, and the only thing I get other than talking to my friends and relatives that I have, we'll say 2,800 subscribers, and I don't have that many friends and family. So that's always a nice thing to know that people watch, and most people kind of like what I do. I have like a little bit different take on things that it's kind of fun to do, and I like learning. And then some of you people will leave some real interesting comments about your experiences, or sometimes some of the questions are silly, but that's okay. So that's kind of what's going on with the channel. I am also reaching out to a few companies to try to get some newer gear. Now, it's kind of just fun for me to test. I get to keep it, and I hope to have some unit. They won't be really high-end things, but they could be a nice little thing to have, like a little Bluetooth amp, line with line inputs, or a DAC built in it. So at some point I hope to be able to have some little contest to give something away that I get. I said I focus mainly on vintage, older things to test, and that's kind of my thing. But occasionally it's nice to get something in that's newer, and I like doing that. It just kind of makes doing this a little bit more fun. If you're curious, I do get paid for videos from YouTube. Basically, you need to hit $100 before they would send you out a monthly check. So it takes me about 3 months to get a check. So you can kind of figure the math. I'm working for maybe $1 or $2 an hour. So it's more a labor of love, but it is kind of nice to have some money for beer or dinner out or something like that with kind of on YouTube. So I do appreciate all your support. So with all that being said, I'm going to get into the review of this Sansui C-2102 audio control center, a preamplifier, but they call it an audio control center. In 1987, you could have purchased this guy for $700, or about $1,924. It's a fairly decent preamp. I think it has a nice look for what Sansui was doing at the time. It has a lot of versatility. It doesn't have a remote control, and it's just kind of a nice standard preamp. I believe it was their mid-level preamplifier at the time. It came to me from my good buddy Ian. It's been sitting around for many years. He wanted me to check it out. It does have a couple issues with it, and I'll talk about that in a little bit. But for the most part, everything functions okay. And we'll take a little tour up the front and then the back, and then I'll have the covers popped off so you can kind of see inside it, and then there will be data, and I'll tell you how it was to use and listen to. I forgot to mention a few specifications for the C-2102. Its THD was rated at better than 0.003%, and it listed a frequency response of DC to 300 kilohertz of plus 0 to minus 3 dB. It also weighs in at a bit over 12 pounds. Here's a close-up view of the Sansui C-2102 stereo control amplifier, or preamplifier actually. Starting on the left, we have our power on-off button with its LED that comes on when it's powered on. We have our 1/4-inch headphone jack here. We have the ability to have 3 tape monitor loops, or DAT players were kind of in that era. And once you select one of them, if you didn't want it on, you would press the off button. Here are our parametric equalizers. We have the low frequency here and the high frequency here. The center knob, the one that has the orange indicator, sets the frequency that the parametric equalizer is going to be centered at, and then this outer ring right here, that sets how much of a boost you're going to get. Now this center one here is detented at the center. The frequency is detented at the center. However, the amount of boost is not detented. Here is our master volume control. It is not detented. If you want to use these parametric equalizer controls, you would press the equalizer on button. Here's our subsonic filter. Here's our loudness filter. And here is our muting switch. Balance switch is here. Here is our dubbing selector for the tape monitor out. And here is our cartridge selector. So you can set it for moving magnet, high moving coil, that would be high gain, or just the normal moving coil. So here are our phono inputs, and whichever one you select goes through this preamplifier equalizer section here for the phono cartridge. So you could have whatever phono you want and then set it to whichever cartridge you want. But if you have a moving magnet, say at phono 1, and you want it to be moving magnet, you go to there. And then for phono 2, if that's a moving coil, and in this case I would only use the high moving coil, you would set it to high moving coil. But it doesn't memorize your setting. Here is our tuner input, and it always defaults to the tuner input when you turn the power on and off. And then we have 2 line inputs as well as another line input, which would be the CD input. This obviously is the rear of the C-2102. You can see our 2 phono inputs over here. They are gold plated. We have the ground lug for the phono turntables. And we have a gold-plated CD input, and then you have your inputs for the tape decks or DAT tape decks, and then you have, your tuner and then your 2 line inputs here. Gold-plated RCA jacks for the outputs, and then you have 2 switched outlets, and this guy actually has a voltage selector if it were going overseas. Here is the inside of the C-2102. The front of the C-2102 is here. This guy right here is the volume control pot. It's an Alps unit. It does have a few areas that had some issues with it, and I'll talk about that later in the review. But this is actually a guy that might be able to replace with some other switch, but it was working good enough for doing the testing. And then you can kind of just see that all the inputs are switched through relays, which helps in high isolation between your inputs, and it kind of just gives an idea as to what's going on inside this guy. And from the bottom, this is what you see here. Here's our standard THD SNR plot at 1 kilohertz with a 2 volt or 6 dBV signal going into the C-2102. I'm using the line 1 input, and I've adjusted the volume control to give pretty close to 0 dB gain. There is a specification that the THD should be better than 0.003%, and we're about an order of magnitude better than that. The SNR with A weighting applied should be 110 dB with the line input, and we're 105 dB. Pretty darn good, and you can see the THD plus noise is also around maybe minus 104 dB. So overall, this is pretty much meeting its specifications. Here is our frequency response from 10 Hertz to 50 kilohertz. And this is using the line 1 input, and we have a minus 6 dBV or 5 millivolt signal applied, and that is per the spec, which says that from DC to 300 kilohertz, the response should be plus 0 to minus 3 dB. Well, we're not quite covering that range, but at 10 hertz, we're down, we'll call it 0.7 of a dB, and at 50 kilohertz, we're down maybe, we'll call it minus 1 dB. So it's looking really pretty good over that range. And if you go from our 20 hertz to 20 kilohertz, we're down 2/3 of a dB at 20 hertz, and then over at 20 kilohertz we're only down about maybe 0.2 of a dB. So it looks pretty darn good, and the channels are balanced to better than 1/10 of a dB. Now this is with the equalizer switched out, and I have the balance control set at its detent position in the center. Once again, we're looking at the frequency response from 10 hertz to 50 kilohertz with a 500 millivolt signal applied, and I'm using the line 1 input. What I wanted to do is show what happens when I switch the equalizer in with the controls for the equalizer. It has 2 controls for the low and 2 controls for the high. I want you to see what happens when I go ahead and flip that in. Ideally, you would want that response to remain the same, but let's see what happens. Okay, let's just focus between 20 hertz, which would be this line up here, and 20 kilohertz, which would be the line right here. So we are basically within a half a dB of the 0.5 dB line, but remember we started off out here at 0. So it does affect the response a lot with the equalizer switched in and the controls set to 0. I would say it affects it almost a dB here around 250 hertz, at least for the left channel. The right channel it does not, but it does have an effect. So if you didn't want any equalizer effect at all, you would leave that equalizer pressed out, of course, but then you could go in and tweak it, and I'll do some tweaking of the equalizer controls in a different section of the video. Here is the Sansui's Crosstalk from 20 hertz to 20 kilohertz. I'm using the line 1 input, the equalizer is off, and the signal that's going in is 2 volt RMS or 6 dBV. There is no specification for the Crosstalk. However, you would want it to be better than 50 or 60 dB, and we're doing that up to 1 kilohertz. And then once we get up to 1 kilohertz and start going higher in frequency, at 20 kilohertz we only have maybe 28 dB of crosstalk, depending on which channel you're looking at. So it is not the most stellar crosstalk, but it is pretty linear at least. Right now I'm applying a 0 dBV or 1 volt RMS 1 kilohertz signal to the line 1 input of the Sansui, and I've adjusted the volume control so that it's giving the maximum gain, and we're kind of just looking to see if there's any real increase in distortion or anything weird. I do have the A weighting applied, and you can see the SNR is almost 99 dB. THD is looking really, really low, and our gain is, we'll call it 16.4 dB. There is no specification for the maximum gain. It's just kind of something that I will do to see how much gain we can get out of the preamp before it distorts. So it is capable of putting out quite a bit of gain. We've got almost 7 volts coming out. If I go ahead and increase the input level to 2 volts going in, I've increased the level so that we've got 2 volts going in or 6 dBV, and it still looks pretty darn good. Our SNR is really looking good, and this once again is with the A weighting applied. If I do take off the A weighting, the SNRs will get worse, and that kind of just shows what it looks like with the A weighting off. In case you were wondering what the harmonics looked like, and this is for a 1 kilohertz signal applied, which is our fundamental. It's 2 volt RMS or 6 dBV, and the volume control is set for 0 dB gain. And basically you see that the odd or the third harmonic is just a little bit higher than the second or even harmonic. Here's the standard system noise level test that I run. In this case we're looking from 20 hertz to 20 kilohertz. I have selected the CD input and terminated it into shorts. And what we're seeing is just the noise level of the system. The worst case offender is right here at 30 hertz, and it is maybe minus 95 dBV down, which is pretty low. There is no specification for the noise level. It's just a performance that I measure. Here is a plot showing the C-2102's THD versus frequency for several different input signal levels from 20 hertz to 20 kilohertz. The spec is it should be better than 0.003%, which would be about right here. And so everything below that line would be meeting the spec. However, at the low frequencies, it's maybe 0.008%. That's still pretty darn good here. And then it gets better as you go up in frequencies. And it looks like it has the best THD with the most input signal level. Here's the C-2102's multitone response. And there is no specification for it, but it is showing a distortion-free range of between about 14 to 15 bits. Right now we're going to look at the input to input isolation, and in this case the input being used is the line 1 input, and we've got a 0 dBV signal, so that's up here at the top. You can see it here, the yellow trace is brighter. And what I'm going to do is switch over to the CD input, which is terminated into shorts, and what you will see then is the leakage between the two inputs. Ideally, you would want that signal to be way down in the mud, and we'll see what happens. I'm going to go ahead and switch over to the CD input. All right, so our CD input has been selected and stabilized. And remember, we started off at 0, so our worst case input to input isolation would be about, we'll call it 67 dB right here. And that is mainly due to the 60 hertz power supply leakage. And then we have another big one here at 120. But if you start looking down at the mud here, at the noise in this level, at the worst case, it's minus 80 dB down for the most part, and then it gets kind of better. It's just your power supply noise is creeping up there. But that kind of just shows the input to input isolation. It doesn't specify what it should be. It's just kind of there for your reference only. Here is a plot showing some of the effects of the tone controls and the filters, and I'm just showing the left channel only. This dark blue line going down the center is with the equalizer out and everything is set flat. And the first one we'll look at is the loudness control, and that is this line right here in green. And it states per the spec that at 50 hertz it should be plus 8 dB. 50 hertz would be right here, and we're pretty close to 8 dB. And then it says at 10 kilohertz it should be plus 6 dB, so 10 kilohertz is right here, and we're pretty close to 6 dB, so that guy's looking all right. Then we have a subsonic filter, the one in red. You can kind of just see it here. And that guy is supposed to be minus 3 dB at 16 hertz. And we're not really seeing that. We're maybe down a dB at 20 hertz. And I'm guessing that if we moved it down to 16, we're not going to quite be at 3. So that one may be off a little bit. And then we have the equalizer controls. It's a parametric equalizer, so you have a couple different frequencies and then an amount of boost for low and high. This first one here is 300 hertz, and I adjusted it to plus 4 dB. And you can see it's much more than plus 4. I guess it says plus 4. I don't know if it's plus 4 dB, but it is just the setting. There are no detents, so you're kind of just eyeballing it, and it's pretty close to 300 hertz. 300 hertz would be right here, so we're pretty close to that. And then I did a few others, and you can kind of just follow them if you want. So this guy right here I set for 180 hertz and minus 4, and it's at 200 hertz. That's probably close enough. And I kind of just did a few others. So it looks like the equalizer would do a fairly good job. And just looking at the spec, the equalizer, the numbers on there are not related to actual dB. The minus 4 that I said that I moved it to wasn't really minus 4 dB. It's just the setting for it. Here is the frequency response from 20 Hz to 20 kHz of the Phono 2 input set as a moving magnet phono cartridge with a 5 millivolt RMS signal applied. The specification is that it should be plus or minus 0.2 dB across that band with the RIAA applied, which it is, and indeed it is better than 0.2 dB across the band. We got a little bit of weird stuff going on there, but it's not really that big of a deal. That's what, 0.05 dB maybe. It's just not anything that's substantial, and the channels are very well balanced, and we are at worst case maybe we'll just say 0.2 dB. So it is meeting the Phono specification for a moving magnet cartridge. Right now we are looking at the THD SNR response at 1 kHz with a 5 millivolt signal applied to the Phono 2 input with the front panel cartridge selector set for moving magnet. I should also point out that the measurement is being done at the tape monitor record output. All the Phono measurements are being done there, and there is a specification that the THD should be better than 0.005%, and indeed it is. The signal to noise ratio with A weighting should be 88 dB. I'm going to go ahead and turn on the A weighting. The A weighting is switched on, and it looks like it's between about 81 and we'll call it 76 dB. So it's lacking a little bit there, but overall it's not too bad for a Phono input on something this old. Here's Phono Input 2's frequency response from 20 Hz to 20 kHz with a 250 microvolt signal applied, and I have the cartridge selector set for the high MC position, so that's going to give you the most amount of gain. There is really not a specification for the flatness, but it is pretty much meeting the plus or minus 0.2 dB spec for each of the left and right channels. The channel separation increased. We're probably about a half a dB worst case channel balance between the right and left channels. Here is our THD SNR plot at 1 kHz with a 251 microvolt signal applied to the Phono 2 input with the high MC or the high gain state for the cartridge selection. The specification is that the THD should be better than 0.01% measured at the record output, which is where I am measuring it, and we are meeting our THD requirements. The SNR is given as 70 dB with the A weighting, and we're kind of off from that. We're at what, 55 dB SNR and 50 dB. So we're missing the mark on the SNR using the moving coil high gain setting. Here's the THD SNR plot at 1 kHz with the moving coil position selected. That's just the one that is MC on the front panel, and it has some issues, as you can tell. I'm not sure what's going on with it. It looks like one channel has a lot of gain, the other channel does not. So it has some issues, and this is all that I'm going to show with that particular input. And I did increase the level a little bit to 500 microvolts. Right now we're looking at a plot showing the difference in phase between the signal going into the C-2102 and coming out of the C-2102. In this case, I'm using the line 1 input, and it is the left channel only. The preamplifier output, where the scope probe is connected to, is terminated into a 47K ohm load to simulate the impedance of a standard amplifier. And what we're seeing here at our 1 kHz test frequency is there really is no change in phase at 1 kHz between the input and the output of this particular preamplifier, and there is no phase inversion. Switching over to 100 Hz, we can see there's a small amount of phase shift going on there between the input and output, but it's way small. I don't know what that translates to, maybe 1 or 2 degrees, if that. And going over to 10 kilohertz, we can see that increases a little bit here, the phase difference. It's a few degrees also. It's still not a lot. This plot shows the phase difference between the left and right outputs with the same signal going into the line 1 input. And I should mention that the equalizer is switched off for this. And at 1 kilohertz, there is no difference in phase between the two channels. Here's a plot showing the rise time of the C-2102. And once again, we're using the line 1 input, and we're measuring at the left channel output. Our input is this nice looking square wave here in purple, which has a very fast rise time of 80 nanoseconds. And the rise time of our output, the left channel, is 2.63. There is no specification for it. It's just for comparison sakes. The first thing I do when I get an amplifier or preamplifier is to hook it up to my Quantasylum QA403 analyzer in this case, and just kind of see where the unit's at. And what I noticed was that this guy had a problem with the right channel. And right now I'm just going to play the video I made at that time showing how ugly the right channel looked. And this was at a specific volume setting that I was getting this at. So let me just play that and then I'll come back. Here is what the C-2102 looked like initially before I did any cleaning or lubing. The right channel would occasionally get better if I move the volume control around or the balance control, but you can see how high the distortion is compared to the left channel. And I'm going to go ahead and clean and lube the pots and then come back and see what it looks like. When you see something like that, I kind of pound on it and see if there's bad solder joints, and it didn't seem to be affected by that. So I'm thinking maybe dirty control. So I pop the covers off and I go in and I use a tuner cleaner lube on the controls. Now, as you saw on the tour of the inside of the unit, it has some of these Alps, I call them fancier volume controls, and that seemed to be kind of flaky. I was able to get cleaner lube in that and worked it, and it seemed a lot better. Actually, it would get normal for a while, and it stayed that way. However, it would have a sensitivity to right at the spot, which gave me 0 dB gain, and I could change the input signal to see if it was more something further down the line that didn't like being driven that much. But no, it was definitely related to the volume control pot. Once I tried working that a bit more, and I used a little bit different cleaner lube in there, and that seemed to work fine, and I did all the measurements. And what I noticed when I was all done, I remeasured it again, and it was still a little flaky. Thought it might be some solder joints where the connectors are wired to that volume control pot. There's there's a wire harness that is soldered to that control board, and it goes to another board. And I retouched the solder joints because it seemed sensitive, and it worked better, but it still has that kind of issue. So ultimately, I believe that pot, that Alps pot, is bad. I didn't see where you could find one online. You probably could replace that with another 100K pot. I don't know if it's a linear taper or audio taper kind of a pot, but you probably could rework it. But I figured, well, I'll just see how it does during the listening test. So I'll talk about that in just a little bit. So anyway, that's kind of like a little history with the unit. And the other thing you saw from the data was that the normal moving coil, it has a high moving coil position and a normal, I'll call it a normal moving coil position. That was bad. So the normal moving coil position, there's something wrong in that part of the circuitry. Now, the regular moving coil seemed to work okay, but it wasn't the highest SNRs I remember on that. The normal moving magnet position seemed to work fairly decently as a phono preamplifier. So if I were using this, the moving magnet would be the way to go on it. Now, the data showed that it has fairly low noise, and one thing that was unusual is that when I cranked the gain all the way up, it still didn't distort with a 2-volt RMS signal going in, which is a fairly large signal for a preamplifier. And you saw the data that showed how much gain, but the preamplifier looked really good at maximum volume, which is not normally what I see. Pretty low noise, The frequency response was pretty good on this guy. So as far as, you know, all the features on it, it seemed to work really good. So normally if you press in the equalizer circuit, you would like everything to be flat. This one wasn't really flat, but if you're going to be using the parametric equalizer, you're going to be adjusting settings anyway. So there would make, it's not really important that it's not flat. It's more of a, oh, okay, this is what it looks like. On certain preamps, it'll look not much different when the equalizer is in and out. So overall, I thought it performed electrically really nicely. It's got 3 tape inputs, which could be used as auxiliary inputs if you wanted to use that. It's got 2 auxiliary inputs or line inputs, and it has a tuner input. And then the phono input, as I mentioned, is one that you can switch. Either phono can have the moving magnet or moving coil position set for it. So if you had 2 turntables and one was a moving magnet and one was a moving coil, all you would have to do is set the cartridge selector switch for that, I guess you would call it. So that's kind of cool. One negative thing that it has is when you power it off, it always goes to the tuner. So it doesn't remember the last state, line state that was in, or if it's set for phono, if it's set for the tape position, one of the DAT tape positions, or if it was set for, you know, line 1 or 2. It doesn't remember that. It's always going to come into the tuner when you power it on. So that's kind of like a little negative, I thought. But other than that, you know, it's a nice basic unit. Now, as far as listening, I hooked it up to my Carver M400A little cube power amp, and that was hooked up to the Wilson Watt 3 Puppy 2s. I let it play for quite a while, and it did really good. I don't really have any complaints about the sound at all. The only thing I noticed is once I got to a position, I think it was around 20 on the dial, it was lower than the 0 dB gain point. I did hear a bit of scratchiness in it, and then when I got up to around the 0 dB gain point, which is I think 16, 15 on the dial, it started getting some distortion. Some of that was acting up, and then you could move it a little bit and it would go away. So that pot does have a bit of issues. However, when I was listening to it at the 0 dB point, I was, you know, 96 dB SPLs. It was pretty loud. The Carver was cranking, and I'm not sure how many people will be playing that loud. So if you're if the person who ends up getting this, because my buddy Ian sells stuff, if he has an amplifier with a reasonable amount of gain, the Carver's 29 dB, I believe, for the cubes, probably you're not going to really notice that volume control, that little spot in there where it's actually spots where it starts goofing, you know, up, getting scratchy. But, you know, on older gear, sometimes that happens. Maybe people take apart those Alps things. There are some screws on it, but that's not anything that I would want to get into and see if I could repair it. So it's to me, it's usable, and for most people, probably they're not going to be moving the volume control that far. So other than that, it sounded great. It works really good, and you know, it would be something that I would recommend. It's got a lot of versatility. I think it has a nice look with the colors and all that. So that's kind of my take on the Sansui C-2102 preamplifier. Please leave comments if you have them, or stories about your experiences with it. Or any gear, a lot of times people talk about something else related to what I'm doing the video on. Thumbs up if you think it's worthy of a thumbs up, and if you have not subscribed, please do so. And until next time, have a great day or night.